Hello everyone, welcome to our channel Higher Mathematics. In this video lecture, I am going to discuss the next PYQ of real analysis asked in CSIRNet 2020. So our question is, which of the following statements are correct? Here, some series are given and we have to check the convergence or absolutely convergence of this series. So one by one we will discuss each option. So option first is said, the series this is convergent. So option A, what is the series? Summation minus 1 to power n upon root n. As this series is what? This series is alternating series, and this series is alternating series, and by Leibniz test each term of this series is what? Less than the alternating series, is just like a1 is less than a2, greater than a2, greater than a3, greater than a4, and so on. Every preceding term is less than the first term. That is, if 1 upon root 2 is greater than 1 upon root 3, is greater than 1 upon root 4, and so on. So this, and first condition is this, and second condition, limit n tends to infinity, the series what? Minus 1 to the power n upon root n is equals to 0. So both condition is satisfied. So by Leibniz test the series is convergent. So option A is correct. Now option B, same as this question only, this series is what? Convergent. By, as every preceding term is decreasing and at limit n tends to infinity the series is equals to 0. So by Leibniz test this series is convergent, but here we have to see the absolutely convergence. So what we see, that for absolutely convergence we have to see the positive term of series. For B, for absolutely convergence, mod of minus 1 to the power n upon summation n plus this, which is equals to 1 upon root n plus n. So by comparison, limit comparison test, we can say the series is divergent, not convergent. If we let un is equals to 1 upon root n plus n and vn is equals to 1 upon what? N, then by comparison test the series is divergent. So if the series is divergent, then it is conditionally convergent, not absolutely convergent. So option this is wrong. For third option, here we have to split this series into two different series, one by positive terms and one of even terms and one of odd terms. So let me see the series. This series, let the series name an is equals to log n upon n to the power 3 by 2 when n is odd. If n is odd, then the series is what? This, if the series n is odd, n is equals to odd, then this becomes the zeroth or left option this, and it is even, then what is become? 2 root n plus log n upon n 3 by 2, n even. If n is even, this series is this, and if odd, then this is this. As the series is convergent, this, if this series, let this is a1 and this is a2, if series a2 is equals to 2 root n upon n root 3 by 2 plus log n upon n 3 by 2, this series is convergent, but this series is not convergent by P series test. The series is equals to summation 1 upon root n. By P series test, this series is divergent. So whole series, this series is divergent. So option this is also wrong. Next we have to see the third option. What is the fourth option? This series is also convergent. Same by Leibniz test, this is series alternating series, so we use a Leibniz test, each term is decreasing and at limit n tends to infinity this is equals to 0. So this series is also convergent. So option A and D are correct. So this is the required solution of this question. Here we have to use a Leibniz test for the convergence, what Leibniz test said, if limit n tends to infinity, n is equals to 0, and second, each term is less than the first term. First term, just like this, first term is greater than second term is greater than third term. This set Leibniz test, these two condition, and limit n tends to infinity, an is equals to 0. These two conditions are of Leibniz condition. If this series are following this, then series are convergent, and for absolutely convergent we have to see the mod of that series. So this is a simple solution of this question. If you like this video, hit the like button, and for more such video you can subscribe my channel. Thank you for watching.